was slope of a line, section 3.3. Then, after that, hopefully we'll have time to rotate in our groups and continue what we did yesterday. Last class, it took a little while, we didn't have too much time to rotate, so we did something else again, but we'll try and see how we can do that. Okay? Alright, so for this first problem here, what do you know about the values of A and B if the line AX plus BY equals C has the property described? It has the property described. Questions? Good? Has the property described. Now, notice, first of all, what form is this in? What do we call that form when it's AX plus BY equals C? Standard form. Standard form. Now, if you watch the video, you'll see that I derived the slope in standard form. Anybody remember, what is the slope of a line that's in standard form always equal to?
Negative A would never be A.
Close?
Negative A would be.
There you go. That's my slope. Always, always, always. You know why? Because it's in standard form. And if you go to solve for y here, you're going to get y equals negative A over b plus c over b. I'm sorry, negative A over bx plus c over b. So the slope is negative A over b whether you memorize it like this, or if you want to solve for y, you'll get the same thing. But I recommend that for these types of problems, just please memorize this. God bless you. Please memorize that the slope is negative A over b.
So A represents X and B represents Y.
A represents
What's multiplied in X?
good, which we call the coefficient. Okay? Coefficient, very good. Now, for this problem, we want to know, what do we know about the values of A and B? Do we know something about A? Do we know something about B? Do we know something about both? Depending on the property described. So let's start with part 1. The line is horizontal. The line is horizontal. Somebody tell me something about a horizontal line.
Y equals 0.
Yeah, or not just, it can be y equals any number, but what equals 0 always?
X. I mean, the slope.
There it is, good. I knew you had it, I recall. Whenever you have a horizontal line, it's a flat line, right? The slope is 0. The slope is 0 for a horizontal line. So, if the slope is horizontal, or the slope is 0 for a horizontal line, and we know the slope equals negative A over b, the transitive property of equality tells me just to set them equal. This equals the slope, this equals the slope, they gotta equal each other, so do it. Alright, so far so good. Well, when do I ever get 0 as a quotient? When I divide what kind of numbers? What do I know about the numerator and or denominator? How am I going to get a 0 there when I divide? Joe? Be careful. Very good. So you're jumping ahead now. Here, the top has to be some 0 value up here. 0 over some number gives you 0 always. So this tells us that the numerator must be 0. So negative A must be 0. That's a 0, not a 6. Well, if negative A equals 0, if I divide by negative 1, A is just 0. So for part 1, we know that A must be 0. That's all we know. Because we know the slope is 0, so the numerator of the slope must be 0. And that happens to be A. Joe, follow up, because you already answered kind of. Follow up. Second part.
Vertical line.
Vertical line. Go ahead.
Must equal 0 because it's undefined.
Yeah, good. The slope of a vertical line is undefined. Do we all remember that? A vertical line, it has no slope, as your textbook would say, which I don't really like, or we say it's undefined. Well, Ryan, how do we get undefined? What do we have to have?
We have negative number
Over.
0.
Yeah, any number over 0, right? So when the slope is undefined, it's something over 0. Do I care what the numerator is? Doesn't matter, because if it's over 0, it's undefined. 10 over 0, 100 over 0, a million over 0, it's still undefined either way. So B must be, everybody? 0. Right.
Alright, this is like my math answers. 0, 0, 1 or 0, 0, 0.
It's called indeterminate. time, maybe I'll go over it into that. I can do that for you. But there's a reason for it. It's indeterminate. Okay? It has to do with limits, and we'll talk about that in calculus. And indeterminate really means not able to determine really what the actual value is. Not undefined either, which is very odd. Because you think anything over 0 is undefined, right? So some number, some constant over 0 is undefined. All right, part 3. Somebody give me some instructions as to what I should do. Not the answer, but instructions.
Yeah, so, negative slope.
Why negative? But it rises from left to right. So does that mean this? Left to right, and it's rising.
Oh, okay.
So what kind of slope? Okay. No big deal. It's all right. Again, rises from left to right. Here's the left part, here's the right part, and it rises. It goes upward. So positive slope. So for part 3, we know already that the slope is greater than 0, or it's positive. The slope is positive, the slope is positive, the slope is positive. But the slope is negative a over b. But it looks to me like this is going to be a negative number, right? Because you see the negative there. A lot of people assume that it's got to be negative. But what can I do? What can I make a to make this end positive, Kate?
A negative?
Yeah, what if a is negative? So again, for this third part, if this is a negative here, if I make this a negative and make this a positive, I end up getting a positive slope, don't I? So if a is negative and b is positive, this will work. So let's write that. A is negative. Let me scroll down a little bit. If a is negative and b is positive, and you can write in words, but I'm trying to use inequalities more and more here. So when a is negative and b is positive, we get negative, negative over positive, which yields a positive solution or a positive slope. Right.
Can B just be negative?
And a would be
Positive.
good. The other option, remember, is if you leave a as positive and make b negative now. Again, my slope is right here, negative a over b. If I leave a as a positive, but make the b negative, the negatives then cancel, right? And what do you get here? Positive. Careful. Positive. I heard that. So let's put an or statement, because either or work. Again, a can be negative, b is positive, or a can be positive and b could be negative. Remember though, you must have both conditions. That's why there's an and symbol between them. The or symbol means you can have either of these conditions. So, if a is negative, then b must be positive. That's your answer. Or, if a is positive, then b must be negative. The and statement indicates that both things have to happen together. The or statement means that either one of them could happen. All right, the last part. It says the line falls from left to right. Falls instead of rises. So what kind of a slope, everybody, are we going to have here? Negative slope. All right? So for number 4, if I want it to be a negative slope, I say m is less than 0. That's my negative slope, right? So I've got my quantity negative a over b. If I want this to stay negative, what should a and b both be? Joe? Positive. Brian? Or both negative. Very good. Remember, if I make a and b both positive, I get negative, positive, positive, which turns out to be negative. But if I make both a and b negative, I get negative, negative over negative, which is still a negative. So either a and b have to both be positive, or a and b have to both be negative. Okay? How do I write that? They're both positive, that's how I write that. Or they're both negative, or they're both less than 0. Okay? Either or work. But remember, if a is negative, then b must be negative. Or, if a is positive, then b must be positive. They rely on each other. They're dependent upon one another, these conditions. That's clear for this example. This is the kind of problem that you have to be able to do, God bless you. This kind of thinking in calculus. I'm telling you now, just to give you a preview. These are the kind of thoughts you're going to have. So when you talk about things called derivatives and integrals, you have to be able to conceptualize or understand what's going on. not just use numbers. Because clearly, we didn't use any numbers the whole problem. Everybody see that? No numbers at all. But we're able to determine all these values. Number 5, graph a line that has a slope of negative 2/3 and goes to the point negative 2, 4. So, before you start graphing, I got you guys something. Who had the graph paper notebook? Was that you, Ryan? Or is that Jared? It was Ryan, right? So I found these online. So if you want each graph one, they're Post-its. Okay, but they're posted graph paper. They're a little bit bigger. I don't know if it's, that's what if it's worthwhile for your notes. There's 50 per pack in here, so hopefully it'll last you a good amount of time. We're going to do a lot of graphing all year, so just to give you guys a little preview, whenever you want to, draw a quick graph and you don't want to use a whole sheet of graph paper, just use one of these Post-its and stick it right into your notes. There's one for you also. Okay? So, if you run out of them, guys, if you run out of these sheets, you can buy them on Amazon, just type in Post-it graph paper, but they're a little bit expensive on Amazon. These only cost buying them, and I bought them in bulk and a lot of them, they only cost $1 per pad. On Amazon, they're $3 or $4 per pad. So if you buy them on Amazon, they're just going to be a little more expensive. Obviously, it's up to you guys to decide for one more. So graph a line that has a slope of negative 2/3 and goes to the point of negative 2, 4. Let's use our graph paper here. So we start with the grid. All right, so we've got a graph. Now, what should I do with my axes, people, from your test? A lot of you saw this. What should I do? Label them. So what is this axis called, Brian? And this axis? Because you're going to learn, it's kind of crazy. Later on in life, you might switch that in math. Yeah, I know, right? Isn't that wild? But you might switch the axes. You might call this Y and call that X, actually. And you're going to see that in physics, and you'll see that in calculus, both. Okay? Now, for the sake of this class, and for the sake of algebra 2 and all that stuff, this is the XY axis. But please label. What else should I label? One other thing. Joe.
All it said is name the line.
Not yet. We will. Okay?
What intervals should I?
Yes, very good. The intervals or the increments. By what increments are you going? I'm going to go by ones. So I put a 1 there, and I put a 1 there, and I'm done. You do not have to label more than that, but a lot of you didn't label anything on your test. How did I know you were going 2, 4, 6, 8, 10? And some people did use 2, 4, 6, 8, 10 on the test. Some people went by 4s. 4, 8, 12, 16, 20, 24. I don't know, unless you label. If you label a 1 on the Y and the X-axis, you're good to go. Remember, you can go on the X-axis by 1s, and you can do the Y-axis by 5s. Nobody has a problem with that. But you need to be consistent along that axis. So if your X increments are 1s in this direction, these are also in the negative direction, assumed to be 1s also. Is that clear? Everything is going by 1s now, because we labeled a 1 in both spots. Now, if I want to graph this, I go to the point. Well, negative 2, 4. How do I get to negative 2, 4? Somebody direct me, please. Dan, Nicholas, sorry. Agree, disagree? Try one more time.
Oh, I'm sorry.
It's all right. Good. I knew you knew you just made a little green part there. So I go over 2 to here, and I go up 4 to here, and I find where they meet, and there's going to be my point right there. So there's my first starting point. Now, the reason I'm doing this problem, and it seems so trivial, I know that, is because negative slopes have a tendency to confuse some students. Tell me, Jared, negative 2/3, how can I write that? There are several ways to write it.
Put negative 2 as the rise and 3 as the run.
Good. Or,
The slope is negative 2/3.
but I mean, what can I do with the fraction instead of putting the negative up top?
Oh, negative 2 times 1/3.
That works too. You give me very good answers. You're right. Totally correct. But what I was looking for was this thing.
Oh,
See how the negative can be the top and the bottom? Sorry. So Jared's right. His answers are all correct. Negative 2 times 1/3, same thing. So what I want you to see though is this. The slope can be interpreted either way. Now, I like the way you said in the beginning, -2 is the rise and 3 is the run. Or 2 is the rise and -3 is the run. So in this kind of a problem, let's use the first one here first. So -2, this is really delta y. This is really delta x. Remember, slope is delta y over delta x. Delta means, everybody? Change. So the change in the y is -2. So what do? I start here, Ryan, and where do I go? Down 2 for the delta y, and then to the right 3. This means right 3, this means down 2. Again, this means down 2, this one is to the right 3. Ryan, how did you know it was down 2 and not up 2? But for this slope over here, how do you know it's down 2? What tells you down? And then to the right is because this is positive. Just to be clear. So we go down 2, we go to the right 3, and we're over here. Go down 2, right 3, it's going to be here at this point right here. And I'm going to connect these two. Okay? It's not a curve, it's just a smart board acting up. It's a line. It's a linear function. Okay. Now, that's one way of doing it. Chris, can you step me through the second way of doing it? Instead of using this method? If I were to use this, what would I do?
You go up 2 and 3 to the left.
Well done, sir. Again, up 2 and 3 to the left. It's the same thing, isn't it? Go up 2, everybody. 1, 2. 3 to the left. 1, 2, 3. Well, here's your point all the way out here. Connect this. You're still on the same line. Again, here's your point out here. Okay? You're still on the same line. Doesn't matter. Is that clear? Doesn't matter. What's important? What's important here, really? Okay, did you know the formula? Good. Delta y, delta x, good. But what's important about the graph at the end? What do you want to make sure? The line is what? Straight. Good. What else? What? Labeled. Okay, we can label the line. We should label the line. There's no, we don't have the function, so we're not going to label it, actually.
Has arrows, is that array?
It has arrows, so it's not array. Good. Arrows on both ends. What else? Linear, which is a line. Why is that? But what about its slope? Its slope is what? Negative. If you graph this, and somehow you get a line that looks like this, and you were told that the slope was -2/3, what do you guys do? Yeah, go back and fix it, or find your mistake, right? Find the error in your work. Okay? All right, last example, here's what I want you to do. And do this one step at a time. Go to your calculator. In Y1, graph 1/2 x with parentheses around the 1/2. We're going to graph a family of functions, y equals ax, where a takes on these values. Graph that in Y1 and graph it. Hit enter. Okay? Pause for a second. Let it graph. Then go back, and then put in the other ones. And what I want you to put in are these. And I want you to graph them together, but graph the first one first, 1/2 x, hit graph, then go into the other ones and graph those.
Dude, what is the second one?
1 times x, this is x. I'm trying to show you because look, we're using the coefficients 1/2, 1, 2, and 4. So there's really a 1 in the front. You don't have to put this 1 here, obviously. Just put y equals x. So again, graph this one by itself. Look at the graph of it. Then go ahead and put these in the other y equals terms. If you don't have a calculator, look on somebody, please. You guys got to bring a calculator to class. Come on.
Who doesn't have one?
Yes, chair. Sorry.
Oh, wait, which one do you work? Sorry.
Say again.
Wait, so then we go back to y equals.
And in y2, y3, y4, put all the other equations.
Okay.
I'll show you. I can show you on the calculator I have here. So in y equals 1, put 1/2. X. Now people, watch what I'm going to do. if your graph for some reason doesn't look like it's a normal axis, like 10 by 10, you want to go and press zoom, and then number 6. See the word standard? Standard zoom is 10 by 10 graphs. That's y equals 1/2. Now, what I want you to do after that is go ahead and graph y equals 1x, y equals 2x, and y equals 4x. And then hit graph. There's 1x. There's 2x. There's 4x. What do you notice is happening to the line every time? It's getting what? What's the word? Steeper. The slope is increasing. We went from 1/2, then we went to 2, like 1, then we went to 2, then we went to 4. The slope is increasing, so the line should be getting steeper. Now, try the same thing, but insert a negative sign. Watch, let me show you a little trick. Second, insert, then press the negative sign down here. So you don't have to retype it every time. Second, insert, negative. Second, insert, negative. Go down again. Second, insert, negative. You all see that? Make it easier for yourself. Then hit graph. There's negative 1/2. There's negative 1. There's negative 2. And there's negative 4. Again, it's getting steeper, but in the negative direction now. It's getting more steep in the negative direction. In the negative direction. Questions on this? Questions? Yeah?
Are you sure you guys understand what like inserting is? Because this guy was really giving you a lot of tricks so you can do things quickly. I know that's confusing.
It is true though, she's right. Whenever I tell you these things, guys, like insert and delete and these certain functions on here, like the answer function, the entry function, we'll use those this year a lot too. It makes things a little bit easier. All right, please copy down your homework. Now, what you're going to do this weekend, and I'll explain exactly what you're going to do, and by weekend I mean over the next 5 days, really. You have, again, tomorrow your PSAT, and we have a few more days after that. We're not done with class, I'm just going to go over what we're going to do. This is your homework from section 3.3. Okay, this is the homework from 3.3 you're going to work on. Yeah, it's also on Moodle, so if you don't want to write it down, it's on Moodle, whatever you like. Now, there's also homework from section 3.4 that I'm going to go over in a minute. What I'd like you guys to do also, though, and I spent a good amount of time doing this last night, I recorded another video for you to watch. I think it really will help. Section 3.4, I recorded 2 examples from section 3.3, and they're good examples to look at. I then recorded 5 examples from section 3.4, because I was a little bit hesitant to see if we could get through the rotations today. So I recorded 5 example problems from section 3.4, and they're right out of the textbook, so you can follow along with them. And they're like your written exercises, and I put down the number on the page. It's 20 minutes total, the whole video. So over the next 4 days, watch the video, do section 3.3 and section 3.4 homework. You don't have a problem set aside right now, so this is a good amount of work for you to be working on. Do me a favor, hit file up here. You still writing? I'm getting to 3.4 now. Hit file and go down to right here, 3.4 now. Third one, there it is. No? Thank you. So here's the homework from 3.4 at the bottom. 3 through 48, multiples of 3. And then the self-test, numbers 1 through 10. So you have 3.3, 3.4, and the video. Here's my recommendation. Watch the video first, then do 3.3, then do 3.4. Then I put that in that order on Moodle so that you do it that way. Now, you might be saying, where is the video? The video is under videos from class, but obviously it's not from class. It's a video that I recorded on my own. It's going to say section, it's in the homework, but it's going to say section 3.3 and 3.4. Okay? You'll see 3.3 and 3.4, sample problems solved. Sample problems solved. When I put this video up later, it's going to say 3.3 and 3.4, summary, or loose ends kind of. Okay? Summary. Yeah.
I would really pay attention to that video because Mr. Howell never messes up on directions, whether it's point, slope, intercept, or, I don't know,
instances. And you're going to learn that in calculus where it really comes into play. When you need to use y equals mx plus b, or y minus y1 equals m parentheses x minus x1. Or standard form, ax plus by equals c. Any of those three work. It's a matter of when you're going to need to use them. You're going to be able to choose them. But for the class for algebra 2, I want to make sure that we know how to do all of them. So when you get to calculus and you're working with Mr. Linus, you're more than prepared to do that. So that you have enough tools under your belt to solve any type of problem. Okay? Now, there are 10 minutes left. Let me give you an option. In the other class, what I did was I simply went over each of these three things, and everybody took notes. And I went over like an example of each. And I asked people to help me that studied them yesterday. I could also let you guys rotate, but you might not get through all three if you're rotating. It's up to you to decide. What would you like to do? Rotate?
How about we take a vote?
Let's
Everyone
take a
who
vote.
wants Mr. Howell to teach it, raise your hand.
It's going to be split, of course. 1, 2, 3, 4, 5, 6. And then rotate?
5.
No vote?
No vote. So
6, 5. We will definitely do another rotating session. I know a lot of you like to work with each other, that's fine. The only reason I'm giving this option is because I think we're going to run out of time. You might rotate once and that's it, and then you're not going to learn all the three things that I want you to go through. But in 10 minutes, I can do an example each. But here's what I'm going to do. Here's what I'm going to make it a little bit more intriguing. Who did Mike Slope yesterday? Who did this first one? Show of hands. 3 people did this. Joe, Alessia, and Nick. Somebody that's confident step me through how to do point slope. And I can help you through it, I don't mind at all, but I want to do an example of point slope.
I do. So
That's true, man. That's not a bad idea.
because I have the markers where one of them's not, and then we can explain it. Or do you want to do this one for it?
You know, just go to Smartphone for now because I want to record it.
why
I
is
want
it
to record it because it's been recorded.
No, but why is this moving?
It's grabbing. I'll just hit next page. Hit next page.
Okay.
All right.
Thank you.
You want to step me through? Bless you? Okay. Thanks, John. I'll show your hand too. All right. Alessia, give me an example problem. Did you do an example where you were given maybe 2 points?
Yes.
Okay. So give me an example where you were given 2 different points.
1, -2, and 5, 1.
Okay. So, Alessia, this problem is asking for us to do it in point slope form. So I'm going to write that to start. Got to be memorized, by the way, guys. Got to memorize this, okay? It just has to happen. Now, before I can begin this problem, Alessia, I need to know a point and the slope. Well, I've got 2 points, so I'm good there. But do I have the slope right now? So what do I have to do to start this problem?
You have to plug in. So it would be 1 minus -2 over 5 minus 1,
Good job.
which equals 3/4.
Again, 1 minus a negative is a plus. This is a 4. Slope is 3/4. Well done. So now I know the slope. So I can put in a 3/4 already right there. Now, what else do I know?
You know what your y line next one is?
Which one is it though, Alessia?
Well, the first coordinate.
Does it matter though? Remember guys, this point in time, y1 or next one just means a point. Well, both of these points are on the line. So choose this point or choose this point. Which one do you want to choose? I agree with you. I'll go with the positive one. It makes it easier. So here, it's going to be y minus. Sorry, you're good?
And then x minus 1.
All right. Now, the common thing that a lot of students want to do is distribute the 3/4, which you can do, but it makes the problem very messy. Very messy. Daniel, give me hints about it. Good. Multiply the whole thing by 4. Okay?
Or the reciprocal.
You could, but be careful. I
Because the
wouldn't.
reciprocal is 2
But then you're going to get fractions over here.
Yeah,
Exactly.
exactly.
Very good. Very good. You're going to get fractions on the left-hand side. So multiplying on the left side by 4. 4y minus 4. Well, this 4 cancels with this 4. And I'm left with 3, parentheses x minus 5. Alessia, continue. Help me out here. What do I do next?
Then you would, I want to say distribute 3. So you get 3x minus 15. And then on the other side you have 4y
That's why we're doing all this work. Because remember, guys, if the problem doesn't say standard form, you could have left it in the first equation we had. Go back up here. Remember this equation, y minus 1 equals 3/4 x minus 5? Quantity x minus 5? You can leave it like that, that's correct. But it's not in standard form. So if you need standard form, then you need to be able to manipulate it. And there are times when it is useful to have standard form. So that's why we're doing this.
Then you would subtract the 4. I'm sorry. Add 4 to both sides. And then,
I want to move the whole 3x over.
so just, divide
Be careful. Remember,
subtract the 3x, so you get 4y minus 3x equals 8y.
good. Now, standard form does say ax plus by equals c. So if I wanted to write it in standard form, I should really write it like this. Again, not that it matters, though, just so you know, okay? Now, your textbook has a huge tendency to want x to be positive, its coefficient. So what would you do to make everything, or to switch this to a positive? Yeah, divide everything by -1. Is that what you're going to add, Ryan? Again, does it really matter though? No, makes no difference. Again, this is standard form, and so is this. They're both in standard form. Even this one is really standard form, but we should have the x first, just to be consistent with A and B. Okay? Hey, let's do a quick check, people. Let's do a quick check.
Why should you add scripts?
So we know that this is A and this is B, just for consistency.
Oh, okay.
And Daniel, that's what the check is going to be. Take a look. What's negative A over B? And then the slope? What's negative A over B turn out to be here? Yeah, -3 over -4, which is 3/4. Well, what did we get for our slope earlier? Didn't we get 3/4? Go back one page here. There it is. We got a slope of 3/4 right here. Okay? All right, let's do a second problem. The second example was slope intercept, which is y equals mx plus b. Who worked on that? Right? You want to step us through an example? What do you got for me? Give me an example where you're given 2 points.
I don't have it with me.
You don't have one with you. Okay, let's do.
I can do it by head.
Make one up. Give me a slope, right? You can make this up. Come on.
Well, M equals 6.
Make it tougher. Make it a fraction slope.
Fraction. Like 6, 8, 5/8.
All right, that sounds good. And give me a point. Okay. So, if you're given a point and a slope, you would probably use point slope, right? But let's say this problem wanted you to practice using slope intercept form. Which you probably wouldn't do with this example, but say it did. Well, the slope is 5/8. Slope intercept form.
Y equals 5/8 plus B.
Good. Now, Ryan, I can't do this problem because I need to know what B is.
You plug in for Y next.
Yeah, take a look, guys. Remember, this point is on the line right here? If this point is on the line, this goes in for x, this goes in for y. Because a point is a solution to the equation. The point, this is very important you understand this. This point is a solution to the equation because it lies on the line. So you can plug it in because it's a solution. 4 equals 5/8. All right, what would you do next?
Simplify the 5/8 times -2.
Okay. Works.
Or you can add -2. Add 2 each side.
They're multiplied, so you can't add it. Right? You can't add 2 because this is a multiplication here.
Divide.
See the 8 there again? Remember that 8 down there?
Multiply the whole thing.
Yeah, I multiply the whole thing by 8 again, guys, to be honest. Just to get rid of that 8. On the left side, we get 32, right? Over here, this 8 gets distributed to this thing and to this. Well, the 8 over here cancels with that 8, leaving behind -10
Plus 8B.
plus 8b.
You add 10.
We
Scroll me down a little bit. Leave what's up. Lee, what's up here?
Why
Yeah.
don't you multiply the 8 times the -2?
Because remember, this right here, what is this really? This is really -10 over 8.
It's one
Do you
term.
agree with me?
It's one term.
Yeah, these are multiplying. This is -10 in the numerator over 8.
Okay.
So the 8 cancels, leaving behind the -10. Again, this here is -10 over 8. So when this 8 multiplies, these 8's cancel with each other, leaving the -10 behind. And then the 8 has to also multiply with 8.
Big kind of.
Okay? Yes. Add 10, 42 equals 8b. Divide by 8. And if I want to reduce that, 21 over 4. Okay? I'll leave it as a fraction for now. Okay? 5 1/4. Very good. 5 1/4. Now, my equation would look like this. What's the slope again? 5/8, right? There's my equation. If I wanted to put it in standard form, if I want to put this back into standard form, how do I do that?
Subtract 5/8 x.
Yeah, but before that, try and get rid of those fractions again. Multiply everything by 8. If I want to put this in standard form again, multiply the whole thing by 8. This becomes 8y. This 8 and this 8 cancel, leaving 5x. 8 and 4 reduce to a 2, making this plus 42. Again, 8 and 4 cancel, leaving behind a 2. 2 times 21. 2 times 21 up here gives you the 42. Okay? Now it's a lot easier, isn't it right? And then, the book does it this way, just to be careful what you can make this. Nothing matters.
Eight
8y.
what? 8 what?
Be careful, it's an x. Okay, so again, both of these answers are more than acceptable for standard form. Your book has a tendency to make the x coefficient positive. This is more than acceptable for point slope or slope by intercept. But, Joe, what did you say before 20 over 4 was? Yeah, 5 1/4. So I would do this. If I were to leave it, I would leave it like that. If I were to leave it in slope intercept form. Remember, guys, section 3-3 homework, section 3-4 homework, watch the video first. The last one we're going to get to just now was perpendicular and parallel. Not very tough, and I did a bunch of examples of those in the video. Please watch the video. I'm going to give you your problem sets when you get back on Monday. They are graded, but I need to look at a few things still.